Hi, welcome to 5.3, where we are going to discuss vision. Our learning objectives are describe the basic anatomy of the visual system, discuss how rods and cones contribute to different aspects of vision, describe how monocular and binocular cues are used in the perception of depth. So let's start with the anatomy of our eyes. I gotta show you all the pictures. There we go. So here's the eyeball straight from the book. The cornea is the transparent covering over the eye. It serves as a barrier between the inner eye and the outside world. It is involved in focusing light waves that enter the eye. The pupil is that little black dot. It is a small opening in the eye through which light passes, and the size of the pupil can change as a function of light levels as well as emotional arousal. The iris, that's this part right here. It is a colored portion of your eye. The lens is the curved, right here, a curved transparent structure that serves to provide additional focus. The lens is attached to muscles that can change its shape to aid in focusing light that is reflected from near or far objects. The fovea, that's how I'm going to pronounce that. It is back here. It's the small indentation in the back of the eye. The retina, it's over here. Is the light sensitive lining of the eye, and the optic nerve, it's this piece back here. It carries visual information from the retina to the brain. Now we are going to move over to cones and rods, and I'm sorry, but those look like monsters from Monsters, Inc. So let's get into it. Cones are specialized types of photoreceptors that work best in bright light conditions. Cones are very sensitive to acute detail and provide tremendous spatial resolution. They are also directly involved in our ability to perceive color. And that's the cones. So this Mike Wazowski looking guy. No, I guess that would be the other guy. I don't remember his name right now. Anyways, Mike Wazowski's the green one. Anyways, sorry. While cones are concentrated in the fovea, where images tend to be focused, rods are another type of photoreceptor, and they are located throughout the remainder of the retina. Rods are specialized photoreceptors that work well in low light conditions, and while they lack the spatial resolution and color function of the cones, they are involved in our vision in dimly lit environments, as well as in our perception of movement on the periphery. That word's not going to come out of my mouth. It's periphery. Yep, okay. Of our visual fields. So like when you can see in the sides. The next one is our binocular cues and monocular cues. Gracious, I do speak English. So binocular cues, they use both eyes to determine depth. And monocular cues, they use only one eye to determine depth. We use more monocular cues than binocular cues. So that is 5.3, our vision.